for 20 students with a part-time job. That's how much they make per month. And what do you notice kind of immediately? Just take a scan through. So pay generally ranges somewhere around $600 to about $800, except for there's one person who makes a ton of money, who makes $2,000 a month. So that seems a little odd, right? This person seems to have made a lot more than the rest of the people in this data set. So when we have a data value that's far away from the others in a data set, it's called an outlier. And here, this 2,000 score is clearly an outlier. It's more than double what most people make in this particular data set. So what do you do when you see an outlier? First, check for accuracy. Make sure it wasn't a typo, or make sure it wasn't a copying error that you made. If you see a score of 20 when everything else is in the 200s, then maybe you copied it wrong. So make sure that it's actually truly there. And if it's real, what you want to do is not actually include it in the table that you'd make with frequency distributions. Instead, you're going to put a note at the end of the table saying that one score, was outside of the normal range. So let's take a look at that. The reason why we're going to put that, so let me give you one little bit more information. So if you did include an outlier in your tables, it would make the table look really weird, right? You'd end up with tons of empty cells between the outlier and then, frequency of 0 between the outlier and the rest of the data set. So you end up with these tons of empty classes, which makes the data look, and it's harder to interpret. So you can't just ignore it, though, because it is part of the data. You have to report it. So it'd be misleading to not report it. So like I said, we're going to put it in the note at the end of the table just to show that we had this data value, but not include it in the major table that we're going to create. So here's my example of what I would do for this particular data set. So here we're only going to be looking at the data in terms of 19 observations instead of the 20 that we had originally, because we had that one outlier. And so I've done all the calculations, the frequency and the relative frequency. You could also do the cumulative and cumulative frequency and cumulative relative frequency. I haven't done it here. But you could do all of the same things, but now instead of dividing by 20, you divide by 19, because we're only including those 19 in the data set, in the table. And then I have a note here that says one value was $2,000 per month and is not included in the table. So now it's being very clear about what we have excluded. We know that there is that one value that's very high, but the rest of it is based off of the 19 observations of the salaries that are in the range from about $600 to about $800 per month. Okay, so this is basically how you construct the various types of frequency distributions. So that gets you through that part of the course. And now we're going to talk about something slightly related to the frequency distributions, which are percentiles. And it's important because percentiles figure prominently in many educational and business and research settings. So you might have heard when you got your SAT scores that you were in the 83rd percentile, something like this. But what does that mean? Given what we've already talked about here, it's really straightforward what a percentile is. Percentiles are basically the cumulative relative frequency distributions. That's C percent. And basically, as we were talking about with the cumulative relative frequency distribution, the percentile rank of an observation is the percentage of observations in the distribution with the same or lower values. You've seen this before. That's exactly what the CF percent is in any of these tables. So let's take a look at an example, because percentiles are extremely useful in interpreting where a given score lies with respect to an entire distribution. So let's say a student receives a score of 127 on an exam. Is that a good score or is that a bad score? Well, it depends on where that score falls within the distribution of scores. So here we have a distribution of scores for Class A and Class B. So what we can see is that they each class or I can tell you this, each class has 33 students in it. And what we can see is that in Class A, we see that there are scores, most of the scores, 88% of the scores, fall at 126 or below. 91% of scores fall at 127 or below. Now if we look at Class B, things are a little different. Most of the scores are actually in the very high range, right? They're in the 130 to 129 range, and there are fewer scores that fall below 127. Okay. So even the range of the scores are the same, right? We have scores that fall from 130 to 125, but they're really distributed quite differently. So Class A has many low scores, Class B has many high scores. So if the student who got 127 was in Class A, they did a great job because they're at the 91st percentile. They have 91% of scores are at that level or below. Where a score of 127 in Class B is not very good at all. It's the 12th percentile, where only 12% of scores are at 127 or below. So a score itself doesn't really provide that much information if you don't know the actual distribution of these scores. You need to know where that score lies in that distribution. And that information is provided by the percentile rank of the score. So we can see with a class with the same range of scores, same number of people, a 127 can be a very good score in Class A or a very bad score in Class B. So if you have a score, right, you can read its percentile rank from the table. So if I wanted to look at Class A and say what's the score, what's the percentile of a score of 125, I can look at the cumulative frequency distribution or the percentile, and I can see that it's at the 45th percentile. A score of 125 is at the 45th percentile. And a score of 129 in Class A is at the 97th percentile. And if you have a percentile rank, you can read the score corresponding to that rank. So if we look at Class B, and I said, if I wanted to be at the 55th percentile, so kind of in the middle of scores, I would need a score of at least 129. To be at the 99th percentile, I basically need a score of 130. So if a percentile rank is not exactly given in the table, you go to the next highest rank. So in this case, it's 100%, the 100th percentile. And we've just done this with ungrouped frequency distributions, but percentile ranks work the same way for group data, only you can only give an approximation. So let's look at that table of weights we had from last class. So consider the class 110 to 119. Any weight between 110 and 119 is at approximately the 40th percentile by looking at that cumulative relative frequency distribution. So we don't have information about the distribution of weights between 110 and 119, so it's just an approximation. So what weight corresponds to a percentile rank of 75? Check yourself and see if you can figure it out. Right. It's a weight between 130 and 139, because that's basically where the 75th percentile is. You could also maybe say the midpoint of that class, 130 to 139, which would be about 134.5. So in discussing percentiles, we've looked at only the quantitative data, this actual numeric data right now. But it's also possible that you can use percentiles with qualitative data as well, provided that those categories are ordered, the ranked data. So remember, it doesn't make sense to get a cumulative frequency or a cumulative frequency distribution with unordered qualitative categories, because what would it matter if the percent of people with brown eyes in a distribution was the same or smaller than with blue eyes? You can't really say brown and below. There's not really a below, those are just categories. So we really can only use this with cumulative frequency distribution, anything with quantitative or ranked data. We can talk about percentiles. So now there are three final points about percentiles that we should follow. So point one. Some percentile ranks are used so often that they've gained special significance and have been given special names. And these are called the quartiles. And the special name for the second quartile is called the median. So what I have listed here are the three quartiles. At the percentile rank of 100%, that's what it's just called. But if you get to a percentile rank of 75, you could say that you're at the third quartile, Q3. 50%, the 50 percentile rank would be Q2, also called the median, which is that smack dab midpoint. A percentile rank of 25 would correspond to Q1, the first quartile. So some of those are useful when you talk about distributions that are, when you talk about these percentile ranks that are psychologically meaningful. Do 50% of the data fall at or below your score? That sort of thing. Second and third points here. So the second point is that reference groups are important. So because a percentile rank tells you where a score falls within a particular distribution, you can only meaningfully interpret a given score if it's from the same general reference group used to create that distribution. So for example, your friend who's 18 goes to the doctor's office and has his blood pressure taken. He's told the reading is 130/86, and that reading has a percentile rank of 50, so he's basically right in the middle of the distribution. Then your friend's little brother, who's 10, goes to the same doctor and his blood pressure is taken. He's told the reading is 130/86 as well, the exact same reading, but he's told that the reading has a percentile rank of 95, so near the top of the distribution. So how can that be? Well, there's two different reference groups we're using to get those percentiles. Your friend's reading of 130/86 was compared to a larger reference group of 18-year-olds, where the friend's little brother, his 130/86 was compared to a group of 10-year-olds. So when interpreting a percentile rank, always be aware of what reference group was used to create the distribution. So, if you looked at a weight of let's say a weight of 175, for women this would probably fall somewhere in the 50 mid-range, kind of given the general population in the US. But for men, right, that would be a fairly low weight given the general population of the US, where that may be a percentile rank of something like 25. And it depends on, the weight of 175 doesn't mean anything unless you know, or the percentile rank doesn't mean anything until you know what you're actually being compared to. Those reference groups are important. Okay, and finally, the last point is there's nothing inherently good or bad about a high or low percentile rank. It depends upon the domain. So oftentimes people think, oh, the higher the percentile rank, the better it is, but that's not always true. Sometimes having a higher percentile rank is desirable, like scores on an exam. So if the GRE or the SAT, something like that, you want to be in the high percentile. That would mean that, if you had a 94 percentile rank, that means 94% of people had your score or lower. So you did quite a good job. You did better than most. But sometimes having a lower percentile rank is desirable. The time it takes to run a race, or blood pressure. You don't want to have most people having a blood pressure lower than you. You want to have the lowest blood pressure. And sometimes it's good to just be in the middle of a distribution, having a percentile rank near 50. So the percentile rank describes where a score is within the distribution, but interpreting the score, you need to know the